Graham walks 8 blocks from his home to the library. He always walks 4 blocks east and 4 blocks south. So what we're going to do here, we're going to draw a city block. If he's always walking east and south, that means his home is here, the library is down there. So one possibility, okay, we're going to assume that Graham is smart enough that he doesn't get lost on the way to the library, that when he's traveling to the library, he always takes a route that will get him closer. So for example, he could do this as a possibility, but he would never do that. That wouldn't make sense, because he would be backtracking. So if we look at the blue one, take that one away, that blue one we could represent as he has traveled south, then east, then east, then east, then south, then east. That would be an example. Does it make sense that no matter which route he takes, he has to go south 4 times and east 4 times? So if we want to count the total ways that he could go from his house to the library, it becomes an identical questions question like Mississippi. Because normally, with 8 things, there would be 8 factorial ways, but you have 4 easts and 4 souths, so you would have to divide by 4 factorial and 4 factorial. Which gives us a total of 70 ways. Now, another way that we could do this same question is by counting it systematically. And I'm going to show you a systematic way of counting things. First of all, you figure out how many ways could Graham go there. Does it make sense that there'd be only one route to get to that spot? Similarly, only one route to get to that corner. There's no other way without backtracking. In the same sense, how many routes could he get to this corner? There's only one route to get there, just straight. That's the only way that you could get there. There's no other pathways. Same thing with this one, one route, one route, one route, one route, one route. The only way you could get to this bottom corner is to go straight. There's no other pathways that get you there. But if I go to this point right here, can you see that I could get there this way? Or I could get there that way, giving me 2 possible ways to get to that corner. Next, we're going to count how many ways we can get to this corner. I can get there 1, 2, 3 ways. Can you see the 3 different pathways to get there? Similarly, this one by symmetry will also be 3. Now there's a pattern here that will help you. And I'm going to tell you that if you counted, this one will be 4, this one will be 6, and this one will be 4. Now I'm going to see if you can figure out what pattern, what number is going to go here. This one's an easy one. What do you think? Any guesses? For this one right here. Yes. 5. And similarly, this one will be 5. To figure out this one. Can you see a pattern that would tell you what number goes in there? The answer is 10. If I tell you the answer, can you see a pattern now? How did I get that number to be 10? And this is the idea behind it. If I want to get to this spot, which I'm saying there's 10 routes to get there, and I already know there's 4 ways, the only way I can get there is either going from that one this way, or from this one down. It's the only way I could get to that new spot of 10. And if there are 4 ways to get to this one, and 6 ways to get to this one, does it make sense that you add them together to get 10 ways to get to this one? Similarly, this is only a 1 because you can't get there from going down, because you can't ever get above there. So there's only 1 way to get there from the previous one. And so we can finish this off by 6 plus 4 is 10. This will be 10 plus 5 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 15 and 20 is 35. 15 and 20 is 35. 35 and 35 is 70. And we get the same answer that we got by doing the identical objects. Sometimes in these questions, you'll want to use the identical objects. But sometimes you'll have to use this counting method, especially if they, for example, we could do this same question, but say, there's his house, there's the library, but unfortunately there's a lake here. So that takes out options. How many ways can you get to the library now? Now I have to do counting. Well, this is going to be 1, 1, 1, 1. 1, 1, 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 4, 5, 3, 4, 5. But if I wanted to get to this spot, I'd have to add 4 plus the lake. This would still be 4. Because you can't come through the lake. Same thing here. The only way I can get to this one would be 4. And then this will be 9, 8, 9, 17, 17. 34 ways if you added a lake in the middle. Questions for practice on this one? Try number